So let's just continue from the point where we left off. We did the basic integration, we understood the notations, we understood that we were to integrate dy by dx, we'll get our y back. What if we are doing differentiation of a function that has a power over it? How do we differentiate? What do you do? If you were to differentiate it, what do you do? How do you find the derivative of this one?
So we can extend the
Just
bracket.
if it's a power 8 or power 10, we just take,
Then we can say multiply.
we keep the function as it is, we reduce the power by 1, and then we multiply by the derivative of the function. Is this right or wrong?
Yes, sir.
So if I were to break down these operations, I'll say the first thing that I did was I multiplied by the power, right?
Yes, sir.
Then I reduced the power of the function by 1. And then what did I do? I multiplied by the derivative of the function. Is this clear?
Yes, sir.
Now, if I were to do the integration of any algebraic function, if I were to integrate an algebraic function with respect to x, what should I do? If I were to integrate an algebraic function, here I'm being very strict about the point that I'm talking about an algebraic function. Okay, now we must reverse this sequence and operations both, right?
Yes, sir.
What should you do first? Reverse the sequence and operations.
Increase the power by 1.
Okay, increase the power by 1, but okay, chalo sahi hai. Then
Multiply the power
multiply
to
nahi,
power.
operation भी reverse करो ना.
Should divide the new power.
Divide by the increased power and divide by the derivative. So what will this become? The integral of this algebraic function. What will it become? First I increase the power, I get n plus 1, and then I divide by the increased power, and I also divide by the derivative of the function. Is this clear now?
Yes, sir.
That is how we integrate when we are concerned with an algebraic function. Let's try to attempt a few questions from the exercise 3.3. Quickly do all these three very easy questions. What about the first one? If you were to integrate it, x plus 2 will get a power
10.
10, and I'll divide by the increased power. The derivative of the function is 1, so I'll just divide by 1 plus c. Is this clear?
Yes, sir.
What about the next one?
So the power would be 7 and then divided by
Very good.
7 multiply by 2.
So I can just write that I'll take, let me add c,
14.
2x minus 5 to the power 7 over 14 plus c. So what about this one? Again, 2 is just being multiplied. I don't need to worry about that. What will be the power now?
10.
10. And I must divide by 10. And what is the derivative of the function? 3 plus c. I must simplify for my own betterment. Divided by 15 plus c. Is this clear now?
Yes, sir.
Let's see. तो पहले तो जब तक you do not integrate, you make sure that you're consistent with the sign. This is 6 into x plus 1 to the power negative half dx. And now we decide to integrate. So 6 x plus 1 power becomes half, and I divide by half and then increase power 1 and then plus c. So what do I get? 12 square root of x plus 1 plus. Is this right?
Yes, sir.
Okay. And what about this one? First, I'll just 2 cube upon 5x plus 3 cube dx. So this is 8 into 5x plus 3 minus 3. And now we'll integrate it. 8 into 5x plus 3 to the power negative 2 divided by the increased power and by the derivative plus c. So what do I get? Minus 4 upon 5 into 5x plus 3 squared and plus c. Do you understand the simplification that I did after integrating it?
Yes, sir.
Again, just like differentiation, I told you that simplification is an equally important part in all these topics. Students tend to get stuck in simplification and they blame the topic of integration or differentiation.
Sir, I just didn't write the negative whole bracket. I just wrote it negative 5.
Even that is fine, but I'm just letting you know, if you were to solve it further, you would expect it to have a positive power, right? You cannot solve with a negative power. Is this right?
Yes, sir.
3 minus 2x. Now the power will become negative 3. I will divide by the negative increased power and I'll divide by the derivative of the function, which is negative 2 plus c. So what will I get? 3 and 3 cancel. Minus 4. So 1 over and then positive 4. 4 into 3 minus 2x to the power cube plus c. Is this right? Is this what you got? Yes, which here?
Yes, sir. This is what I got.
What about the next one? Let's move on to question number 2. I already know the derivative. How do I find the original function? If I know the
The
derivative, I'll just,
integrate it.
yes, I'll integrate it. I'll integrate this entire thing, 4x plus 1 to the power 4 with respect to x. So what will be my y then? 4x plus 4, 1 to the power 5 divided by the increased power and the derivative of the function. Make sure that you have c with it. Now, how do I expect to find c? Yes, which is
So we put in the coordinates of 0, comma negative 1.95.
negative 1.5 is equals to 4 into 0 plus 1 to the power 5 over 20. Can you tell me the value of c that you get? Is this right? Or are you getting anything else?
Yes, sir. I'm getting also the same answer. C is negative 2.
Very good. Let's attempt a couple of more questions. Okay, what about question number 4? Then question number 4. 5, and then we'll go on to question 6.
So now I'm done.
Third budget.
Part 5 also.
Okay, so what did you do in the first one? First, you make sure that this 10 minus 6 to the power negative half, and it has to be integrated with respect to its cube y. So 10 minus 6 becomes power half. You divide by the increased power, and you also divide by the derivative of the function plus c. So if I were to simplify it, I'll write it as minus 2, 10 minus x plus c. Now, in order to figure out c, you just need to plug in the values of 6 and 1. And what do you get?
So 33.
Sorry, part 4. I'm asking about 4. What is the value of c that you got, bache?
So C is equal to 5.
C is equals to 5. So the equation is simply this. This is what you're getting.
Yes, sir.
Well done. Now, moving on to the next one. So what did you do in this one?
So firstly, you find the value of k by putting the value of x and the gradient.
Very good. We plug in the value of gradient in dy by dx and 2 and the value of x in place of x. So what is the value of k that you got?
So negative 1 upon 8.
Negative 1 over 8. Okay. So now I can say that I can get y if I integrate negative 1 by 8, sorry, into 2x.
No, why don't we just leave it as k? It would be easier for us to differentiate.
Thing. It's the same.
Integrate.
It's the same thing. You're right. You can leave it as k and put k as negative 1 over 8 again. Even that is fine. No need to worry. So now if we integrate it, what do we get? 2x minus will remain as it is. 2x minus 3. The power will become 4. I already had an 8 in the denominator, and now I can multiply by 4 and multiply by 2, and then plus c. So the derivative or the equation will be minus 2x minus 3 to the power 4, and 8 8s are 64 plus c. Is this right?
Yes, sir.
Now you can figure out the value of c by plugging into place of y and in place of x. Now what is your value of c?
Sir, I got 129 upon 64.
I'm trusting you with your value. I'm calculating it. So the value of the curve will be 129 over 64. Is this clear?
Yes, sir.
Let's do one more question. Yes, guys. How will we attempt this one? So let's do first we intend is on integrating the entire the equation of the curve, which was 2 bracket kx minus 1 to the power of 5. Yes. So how do you integrate it to kx minus 1 to the power 6 divided by 6k and then plus c. Now you plug in the value, you can plug in 0 and 1. 1 is equals to 2 bracket k times 0 minus 1 to the power 6 over 6k plus c. So 1 is equals to, then this becomes minus 1 to the power 6 is 1, 2 over 6k plus c. So the value of c will become 1 minus 1 over 3. Again, if I plug in the next point, which is 1 comma 8, 8 is equals to 2 bracket k minus 1 to the power 6 over 6k, and then plus in place of 3 if I write 1 minus 1 over